Welcome back, 6th grade Math and Focus math students. We are moving on in Chapter 3. We are still talking about fractions and decimals with multiplication and division, but if you notice, we're going to apply them to real-world problems. So I just copied some problems that you'll find either in your textbook or on your extra practice worksheet, something similar to that, and I want us to be prepared for all sorts of situations when it comes to a real-world problem that involves fractions and decimals and deciding whether we'll multiply or divide. So for this first one, it says we're given 40 pounds of sugar and they're repackaged into packets of 1/16 pound each. How many packets of sugar are there? Oh, I can picture this. In fact, I can tell you that I know 40 pounds sounds like a lot. In fact, it sounds like the total. That's how much I'm starting with all together. And I'm going to repackage it into something. I'm going to put it into packets. This is a big clue to me. I know I'm dividing. And you know what? 1/16 of a pound sounds like the size group, right? They're telling me what size part I'm going to split this into. So I'm splitting it into 1/16. Well, I really am ready to start. I know that I have the total, so I start with the total, and I'm splitting it up. I'm dividing it. Hiya! I'm repackaging the sugar, and I'm putting them each into 1/16 size packets. All right. So I hope you've seen this before. I hope it looks somewhat familiar, but here I have a whole number divided by a fraction, and we've learned how to do that with models, but there's no way I want you to draw 40 bars. That sounds pretty complex. And showing 16ths would be really time-consuming. So why don't we try a different method? Why don't we talk about reciprocals? Why don't we talk about reciprocal multiplication? Well, to do that, I really want to see a fraction divided by a fraction. And right now, 40 looks like a whole number. How could I make it a fraction? Oh, we'll write 40 over 1. If you remember, sometimes we call this keep, change, flip, or freeze, change, flip. I just think sometimes this K being here helps you remember to keep the first one the same. 40 over 1 is going to stay the same when I apply my reciprocal multiplication rules. I'm going to change from division to his opposite. The opposite of dividing is multiplying. And to flip, I actually want to find the reciprocal of 1/16. Well, that means that they change position with the numerator and denominator, 16 over 1. Oh, okay. I'm really ready to multiply. If you take a look, I'm going to look for cross-simplifying first, and I don't see any. This 1 is pretty low, probably as low as you can go, kind of like the limbo. So instead I need to multiply across. Well, I'll take care of the denominator because I know 1 times 1 is 1. Remember, we are multiplying. If you get two of the same denominator, you still have to multiply them because it's not the addition or subtraction rules we've used in the past. This is multiplication. Now next I have 40 times 16. Well, let me think for a quick minute. I could totally stack that up. 40 times 16, and see what we get. Or I could try some mental math. I'm going to kind of ignore the 0 for a quick minute and say 4 times 10 is 40. 4 times 6 is 24. Well, 40 and 24 is 64. But remember, when I multiply and I have this extra 0 at the back, it's going to put a 0 in the back of my result. I'm going to have 240. You can totally check it out over here with your multi-digit multiplication, but this looks correct to me, and I don't know about that 240 over 1. It looks kind of like an improper fraction. And if you notice, any number written over 1 could really be written as a whole number. 240 is a good number answer. But this is a little embarrassing. I'm sorry you had to see this today in my video. It is missing something. Oh, it's missing a label. So let's dig back in. Might use a different color, might go back and highlight in another way. I might circle what they're asking me to find. How many packets of sugar are there? This is the question. How many packets of sugar are there? Oh, 240. 240 what? They're talking about packets. Not iguanas, not cats, not llamas. 240 packets. And maybe I want to be a little more detailed of sugar. This makes sense to me. You start out with a giant Big Chief sugar bag. Lots of sugar, lots of sweet. Too much, don't eat it. And we break it into little tiny packets. We might be able to fill a lot of little packets. To be continued. That would happen for a really long time. So sometimes I use this idea of visualizing to kind of help myself out. Someone else might say, no way, I'm going to think about a bar model. I know that I started with 40 whole pounds. That's a lot of sugar, by the way. And I'm breaking it into 1/16, 1/16, again and again and again. Remember, I don't want to fill up this bar with little 1/16 because it might not be drawn to scale. In fact, I'm guessing it's not. It says I should be able to fit 240 in here when I'm done, and I don't think I could. But this is the idea. I have the whole, and I'm breaking it into parts. Nice. I'm going to make 240 packets or groups of sugar. I like it. All right, let's take a look at another one that you're going to run into. And this one involves decimals, so this is kind of a good mix of things that we're seeing, and it also has multiple parts. At a quick skim, I see we got a word problem, we have a part A and a part B, multiple things to do. All right, let's dig in and do some reading. So first it tells me I have a roll of ribbon. Oops, let me try that again. A roll of ribbon was 9 meters long. Kevin cut 8 pieces of ribbon, each 8/10 meters, to tie some presents. He then cut the remaining ribbon into some pieces, each of length 0 and 4/10 meter. I'm trying to picture this for a quick minute. I have a roll of ribbon that was 9 meters long. Oh, sounds like this is what I'm starting with. And in this case, it sounds like it's a lot of ribbon. 9 meters is pretty long. Sounds to me like this is the total. So I'm going to kind of code this for myself. I'm starting with the whole. So I'm kind of picturing for myself over here, just so that I kind of get the idea. This whole roll is 9 meters long. Okay, what did it say next? Let's do a reread. I always do that when I'm in a word problem. I have to go back and find that important information. Kevin, oh, that's nice information. But he cut 8 pieces of ribbon. Oh, this is important. He's going to cut, or in this case, take away 8 pieces of ribbon. But there's more to it. I need to know how long those ribbons are. So it says each of them is 0 and 8/10 meter. Oh, that is the size pieces. Okay, so each part is going to be 8/10 of a meter. So it's kind of like saying this. I'm going to take away 0.8, take away 0.8, I'm going to take away 0.8, and I'm going to keep doing that until I take away 8 pieces. So I can kind of picture I'm taking something away here, right? I'm not sure how much. I'm going to have to total this up in a second, but that's a good start. If you read on, next it says he's going to cut the remaining ribbon into some pieces. Oh, he's going to cut it. He's going to divide it up somehow. So not only was this cutting talking about subtracting those 8 pieces, I also had to talk about taking away those parts. There's also kind of a division that was involved here. Just like now, I'm going to cut the remaining pieces. I'm going to karate chop them into let's see here, lengths of 4/10 of a meter. Notice I'm using a coding strategy. I used one line to show that these pieces connected, and I used 2 underlines to show that these kind of go together. So next, when I'm done here, I'm going to kind of start karate chopping. Maybe I'll start on the other end just to kind of separate things. 4/10, 4/10, 4/10, and I keep doing that until I use up all of the ribbon. So the real question is, part A, how many pieces of ribbon, I can think of it as parts, how many pieces of ribbon does he end up with that are 4/10 of a meter in length? Oh, that 4/10 of a meter, that's repeated. That goes with those double underlines, doesn't it? All right, so we need to get ourselves started here. What did this whole bar represent? We started with 9 meters, but we took something away from it. What did we take away? Oh, I have to take away these 8 pieces. And remember, I'm not just taking away 8 as a whole number, I'm taking away 8 pieces, and each of them are 8/10. So that's like 8 groups of, or maybe 8 times 8/10. This is again another way to show multiplication. So secretly right here, there's the multiplication. You might want to show that dot if it helps you. Okay, when I'm done, I'll know how much he's left with. I'll take away those 8 parts and I'll know this piece, right? But I'm not done yet until I figure out how many groups he can make or how many additional ribbons he can cut. So I need to solve this piece first. This 9, I can't do much with it yet, but I could take 8 times 8/10. Let me think for a quick minute. 8 times 8 is 64, isn't it? But I want to use that benchmark idea and say I don't just have 8 times 8, I have 8 times 8/10. I'll still get 64, but remember our decimal bank? How many places over does this decimal need to move? 1 to the left. How about for the next digit? 8's really a whole number, the decimal's at the back. So what's 1 plus 0? Oh, just one jump. One jump to the left. This isn't 64 that we're using up, which is good. You don't want to take away more ribbon than he had. But this could be 6 4/10. You could use up that much ribbon. Well, let's think. 9 take away 6 4/10. I have a little subtraction to do here, don't I? So I'm kind of running out of space, unfortunately. I'll go this way for a quick minute. We might have to erase and make more room in a moment. I have 9, and I want to take away 6 4/10. Here's the problem. This 9 really needs a decimal, because when I'm subtracting, our decimals need to be aligned. So this is really relying on 4th and 5th grade materials that I should still have in my memory. So I might need a placeholder back here so that I can show these steps all lined up. Again, I don't line up decimals in multiplication, but I absolutely do when I'm subtracting. 0 take away 4 is going to be difficult unless I regroup. So let's take from this 9 and leave him with 8. And the 10 he just gave me goes here. 10 take away 4 gets me 6. And if you remember, I get to drop down the decimal because I'm subtracting. 8 take away 6 is actually 2. Awesome. From this piece of the puzzle, I know he's left with 2 6/10 meters of ribbon. Oh, problem. He's not done yet. He wants to do something with the remaining. He's going to take that 2 6/10 and he's going to look right here and say, I want to take 2 6/10 and I want to divide it into what size pieces? 4/10 each. All right, one more step. Here we go. I think I could write this as a quick division. I think I could take that 2 6/10 and dive in with the dividend. I could take that 0 4/10 and make it my divisor. I need to split these or cut them into pieces. Well, how many parts will I get? How many pieces of ribbon can we find? Well, before I can do that, I notice we get to play Simon Says. This decimal here in the 4 is causing me trouble. I want to make this a whole number. So let's take one jump to the right, one hop. If you take one hop to the right, because Simon tells you to, you need to do the same in your dividend. One jump or one hop to the right. Here's your new decimal home. Let's move this decimal straight into our quotient, and we are ready to divide. You might want to do a rewrite step, but it's not necessary if you're okay with the way things look. Again, those original decimals, they're no longer there, are they? 4 goes into 2 not too many times. In fact, not at all. But what if I had 26? Could 4 go into 26? Oh yeah. 4, 8, 12, 16, 20, 24. 28 is too much. So I'm going to go for that 24. 4 times 6 will get me close. 4 times 6 is 24. We'll subtract. See what's left. 6 take away 4 is 2. 2 take away 2 is 0. Double check, is your remaining number smaller than your divisor? The answer is yes. And we have a problem, Houston. If you notice, there's a number left over. I'm in decimal land. It's even better than Disneyland. Sometimes it never ends, literally. But in this case, I'm going to show another place value to bring down. The only number that could possibly be at the back and not change the value is a 0. I bring the 0 down, and I'm ready to treat this like 20. 20 is now divided by 4, and it goes in there 5 times. 5 times 4 is 20. I go ahead and subtract, and it looks like it terminates, or meaning I end with a 0. It looks like this might be done. So notice this 5 had to go in the column I was working with this 0 that we brought down, and this place value is all aligned, meaning I might get a decimal answer. Ah, part A, I'm ready to answer. What did I end up with? I started with a lot of ribbon. I took away some pieces, 8 of them, that were each 8/10 of a meter long. Next, I took that remaining amount, the 2 6/10, and I split it up, karate chop, karate chop, karate chop, and I end up with 6.5. What is the 6.5? What does it go with? Well, if you look back, we circled our question. We said, hey, right here, how many pieces of ribbon does Kevin make? Let's find a spot for an answer. I wish my work was a little more organized for you today. Probably should neaten that up, but because it's late, I think we're zooming. We're going to call it good for today. 6.5 or 6.5, you might think. But again, they gave me decimals, give me decimals back. And it's pieces. How many pieces was the question of ribbon? Part A, ta-da. Maybe you are a person that wants to give me a more complete sentence. You want to talk to me about Kevin and how long those ribbons were. I'll take it. Now, here's an interesting question. What was the length of the ribbon left over? Oh, when I read that question, it makes me think of something. It makes me think that I got a weird decimal a minute ago, didn't I? I had this 0.5 at the back. Maybe they didn't want me to give a partial ribbon. Maybe Kevin only wanted those pieces that were actually 4/10 of a meter long. And sometimes you'll find you're going, you think you get to a final answer and you go, whoa, hold up, rethink that. And that just happened to me here. So in fact, I'm going to change this. I don't think I'm going to say he has 6.5 of those lengths. I think I'm going to say he has 6 whole pieces. So we're going to change this to just a 6. He has 6 pieces of ribbon that met the criteria, that were 4/10 of a meter long. So now it says, what was the length of the leftover ribbon? Well, I know that we had this 0.5 sitting here, but that's 0.5 or 5/10 of the length I wanted. That's like saying 5/10 of, well, I wanted ribbons that were actually 4/10 long. Do you remember 4/10 of a meter long? Oh, this word of, we've talked about it this unit. We will again. This word of is telling me groups of or multiply. So I'm going to take this 0 and 5/10 and I'm going to multiply it times 0 and 4/10. Oh, this is awesome. I do actually know, oops, didn't mean to touch that. I do actually know that 5 times 4 is 20. Problem, that's only when they're whole numbers. So this is helpful. 5 times 4 gets me a fact I'm familiar with, but we need to think about a decimal bank. So I'm going to fix this up in a second. In fact, let's take a quick minute and take this 0 and 5/10 times 0 and 4/10 and build the bank. I know I'm going to get 20 somehow, but I need a decimal included. So let's bank the decimal. 1 jump for the first number, 1 jump for the second number, makes a total of 2 hops. Starting at the back, 1, 2. Oh my goodness. Looks like this isn't 20 meters at all, which would make sense. There shouldn't be much left over after all this chopping he's been doing. So actually this is 20 hundredths. 2 jumps over gets me 20 hundredths. I might put a 0 out front just because I know your 7th grade teachers care a lot about that. And so we should probably care about it too. And we'll show this whole number with that decimal placement in the right location. And it says, what was the length? Oh, I forgot to circle the question. What was the length of the ribbon? Length, what are we measuring in? 20 hundredths of what? Miles, feet, inches, kilometers? Oh, meter. Or meters here. This is the amount remaining. You probably could get fancier on me. You probably could get rid of that extra 0 if you just want to say 2/10 of a meter. It would have the same value. And you might even want to give me a sentence that says, Kevin has 2/10 of a meter of ribbon remaining. Sounds good. Lots of complexity in these problems. Not everyone will be able to get to all the steps at this point, but even if you're not a master of all of these pieces, you can definitely start. Get yourself some partial points by thinking about the bar model. What's it telling you to do? Decode, find the total, box it in, find the parts, underline them or code them somehow. Find that question. I circled it here for you, and I circled the second part of it to make sure I had good labels, pieces, or in this case, a length had to be some type of units or measure, like meters. I hope that your thinking behind decimals and fractions and real-world problems is getting stronger every day. I want you to keep on practicing similar type problems so that anything we throw at you, you can get going on. You take a risk and you dig in, maybe think of a bar model, you decode the pieces, and get partway there, maybe all the way one day soon.